Welcome everyone. My name is Avinash Ramjit. I'm with ConocoPhillips here in Houston. I'll be moderating today's virtual panel discussion titled Breaking Barriers, Drilling Contractors Engage on Interoperability. Today's session is graciously sponsored by NOV's Rig Technologies Group, so thank you NOV for making this possible. Before I introduce our panelists, I'd like to say a few words to set up a framework for this session. The premise of interoperable rig-based system appeals to many well site stakeholders for many reasons and value cases. However, interoperable infrastructure needs to be in place before leveraging any technologies using it. Today, we're going to be talking to several major drilling contractors, both onshore and offshore, as well as a representative from our DWIS committee, to see what may be ahead on our journey towards drilling and wells interoperable systems. We want to make sure this session is valuable to you, so please leave all your comments or questions for your panelists in the Q&A functions within Zoom. You may submit questions at any time during the discussion, as we have 15 to 20 minutes towards the end to answer. With that, I'd like to go ahead and introduce our panelists. To our far corner is Mr. John McPherson. John is an associate fellow with Baker Hughes. He's been in the industry for over 40 years, and he'll be giving us an introduction to the interoperability from the DWIS perspective, focusing on the architecture and the role in automation. After John, we have Mr. Anil Gungada. Anil is the Vice President of Digital Solutions with Patterson UTI Drilling. He's been in the industry for over 23 years and will be discussing reliability and accountability that comes with our interoperable systems. After Anil, we have Andy McMillan. Andy is a product management professional from H&P. He's been with H&P since 2015 and will be discussing the importance of cyber element on our data. Following Andy's discussion, we have Travis McGuire from Transocean. Travis is the Operations Performance Manager and has over 20 years experience in our industry. He will be focusing on how drilling contractors are central to interoperable systems. Mr. Robert Van Gutenberg, the Offshore Performance Improvement Manager from Noble, with 20 years of industry experience, will be discussing data pipelining and transformation. Keep it simple, as Robert puts it. The final discussion will be led by Rafael Gritas. Rafael is the product director at Nabors Industry, and he has over 18 years of experience in our industry. Rafael will be focusing on how to navigate through the complexity of interoperability. Thank you all for taking the time to join this virtual panel. On that note, let's get started. Mr. John, can you please kick us off?
Sure. What we thought we'd do is go through DWIS, which is the Drilling and Wells Interoperability Standards, to set up the framework, if you like, for this discussion, so that everybody's at least knowledgeable about interoperability at the well site. This is a group run by individuals from the oil and gas industry working across different segments, but basically what we've done is we put together a group that's been working now for about 2 years, looking at different areas, such as a glossary for putting interoperable systems together. We all speak different languages, unfortunately. And moving on down, you can see the lists on the left-hand side into the reference architecture. There's some really good stuff on dwis.org, which is d-wis.org, shown there. Be careful to put in that dash. And then there's some demos being arranged over the next few months to show the interoperability system working at different levels of complexity. So moving on, what I thought I'd do is basically go through the architecture, the different pieces. And Robert, who's in the panel here, sitting a couple of people to my left, put together a paper with some of us, when was this, last year? And describing the different components and more of the business side to all of this. But basically the architecture consists of a drilling rig piece down at the bottom, which has an automated drilling control system, and it interfaces at the top to an advisory stack, if you like, of applications. There's some pieces that are needed there. Contextual data is shared among all parties. Any transactions across these interfaces have to be logged. There's an audit trail, and so on. So these are, if you like, the conceptual architecture, the different bits and pieces that we've worked on and described. And then, however, different companies will take that architecture and basically morph it into their business environment. So this is a service company view, if you like, where the service company takes the composer, blackboard, and all the pieces that are used to coordinate the advisory stack, talking to the rig or communicating with the rig. There's signals and semantics being transferred across that link. And there's also, but the really important piece here is the interface. It has to be standard across all ADCSs so that the advisory stack can come on board and just plug and play with the system. For the ADCS, that means that they appreciate exactly what they're attaching, or what's being attached to them. And on the other side, the language is known for the interface to work to attach to the ADCS. And shared among that, of course, is the contextual data. So this is, if you like, a service company view. If you were to look at a drilling contractor's view, then pieces of that would move down into the ADCS stack, the composer, and so on. But the whole system would still function. But the really important piece is that little bridge and the communication to that bridge to the ADCS. So to give you, this is actually a field deployed system and put together by Pedro Arevalo, a presentation that was given last year, and shows what's actually using those components in the field now. And if you look at the name of the authors or the companies involved here, you can see there's a service company, an operator, and an OEM, or provider of the ADCS. And you can immediately see there's a bridge there, although it's called an adapter in here, on the ADCS, an OPC UA interface in this case. It doesn't have to be OPC UA. But on the left-hand side, there's an advisory stack of different applications, tripping, stringer detection, ROP optimization, and so on. And it's working through some composer. Here it's called a little bit different, rig facade. But it actually composes those different, the streams of data coming from those advisors so they can communicate across that link. And at the bottom is a data aggregator, which is shared data from downhole surface and drilling engineering and so on. So these systems are actually in the field at the moment. And now the last slide that my last technical slide, I guess you'd call it, is an overview, a step back out where DWIS is in the overall well construction process. At the top, there's a planning phase that goes through with the operator, service company, drilling contractor, and so on to develop the rig action plan, the trajectory design, a lot of documentation or plans ahead of the well. At the execution side is where DWIS plays, linking, as shown here as a cable, linking the advisory stack of applications to the rig. And then that also means that if you're going to do that, you actually heavily couple the downhole components with the surface components, the drilling components, which is really what we're after into a seamless, interoperable system. So that is a really high-level view of the business, and hopefully we'll get to discuss that here today. But this is my last slide. If you really want more information, there's a stack of information on the dwis.org site. Note down the link there, and in the recording you can actually grab this. There's a lot of technical papers. I don't want to go through that in any detail. So we'll move on into the discussion, and hopefully that has created the architectural, if you like, framework for the discussion.
Yeah,
Okay.
Thank you, John. Anil?
All right. Well, thanks for the introduction, Avinash. So I'm a new member of the DWIS Advisory Committee. I've been with them for about 3 months. I've seen all the work that they've been doing. I'm looking forward to the demos. Thanks for the overview, John. So with that, my focus is going to be more around reliability and safe data exchange in my presentation. Since I'm opening the panel, I'm also going to cover high-level overview of the different systems, what is the current landscape, and then get into some of the challenges that we would face, currently as well as in the future. So with that, here's the high-level architecture slide of what we do currently within our company. Cortex control systems, automation systems is on the left side. That's where we have all the PLCs that are communicating to all the different equipments, top drives, mud pumps, engines, everything else. And then all the data is streamed through a gateway PLC into our Cortex Key platform, which is basically the gateway to all the control systems and everything that happens on the rig location. It's a hardware-software combination. We have infrastructure there. We also have containerized applications that can be deployed in there. And that's what we use to communicate with the third-party service providers. So it could be the EDR, PVT providers. It could be the third-party optimization solutions that come on location or data aggregators. So really what I see is, that is our interoperable solution. That's how we provide interoperability at the rig location. Very limited. Obviously, I'm going to talk about the protocols and all that, but it is there. Will it suffice? We'll talk about that in a little bit. And obviously, once the data is collected, it's also streamed to the cloud. We have a cloud solution as well that is, again, bidirectional solutions. If a customer wants to send parameters down to the rigs, again, that flows into the Cortex Key system, and then from there, it's pushed down to the control systems. So all the automation that's sitting in the control systems is kind of powered through Cortex Key as well. So there is applications and data science apps that you could build that can empower the automation at the rig side. So with that, let's talk about challenges in the current platform, right? So what are we seeing? And this is probably more universal, not just specific to Patterson-UTI. So obviously, the first thing is protocols and APIs, all the several things that we have to support. So the list at the bottom is all the protocols that are out there. There's several more, like WITSML and a few others that are also there off location. But primarily, we are leveraging Modbus for communication at this point, followed by OPC UA, MQTT, and Siemens S7. But again, we need this because we have different OEM providers, different service providers, different data providers. So we need different protocols to communicate. And with that comes some challenges with maintaining the different configurations that go with it. Each vendor or each provider comes in with their own data mapping, data sets, unique configurations that we have to maintain, and version compatibility, a lot of challenges that go with it, right? And then the next one is reliability, right? How do we ensure that the reliability of data feeds is happening? And how do you identify and troubleshoot the issues? And who's going to troubleshoot the issues, right? So a lot of times there is like back and forth that's happening at the rig location while the operations team is getting affected. And for us, automation has been the key. So we have built an alerts platform that allows us to monitor these data points and then identify issues proactively before somebody reports the issue to us. So again, the last point is troubleshooting and identifying these issues in real time, and have people accountable, take accountability for the issues when they see them, right? If it is a service provider, then they need to get involved and take care of it. So with that, DVIS framework, right? So obviously, having a unified framework like John proposed, he was going over earlier, would be ideal. It would help everybody because we could leverage one interoperable framework that we could adopt and have data standards, have API standards, and then comply with that, right? That's easy. That would really help with the second step, which is we can move away from all these custom implementations, custom configurations, and protocol support and all that. We could still have different protocols depending on the need, but at least it's a standardized way to communicate back and forth. Now, a couple of practical issues that I see as we look at adopting this. So I wanted to go through them quickly. So first one is network segregation and cybersecurity is going to be a key thing. So if you're going to open up the controls and automation systems, we have to be mindful about the new cybersecurity guidelines that, as everybody knows, it's very important in the industry right now, and we have already seen some issues. So we all need to make sure that anybody that's coming on location complies with the guidelines, the IEC 62443 guidelines, to make sure that they're compliant. And then data security is also important, role-based security, and application-based security has to be implemented as well. And then addressing liability, that's a big component, right? So when we go into a solution, obviously the drilling contractor is going to be the face of the job, right? So if there is issues with the operational challenges because of data, what's going to happen? How are we going to handle it? Who's going to take ownership on that? And it cannot always be the drilling contractor, which we have seen in the past, and when it comes to contracts and NPT, there has to be some leeway in there to say, how do we handle that? If it's something goes on for more than 4 hours, and we are talking about non-productive time, so how do we balance that as well? And last one is resource commitment, right? So there's going to be cost involved in adopting any new framework, any new implementation, and how we're going to pay for it, the direct and indirect costs, right? And that'll help us build a robust interoperable solution, but we have to be mindful of these things. So in conclusion, what I'm going to say is an open source interoperable framework is the need of the hour. We need it as an industry. Once it's in place, we can all use it. And all stakeholders have to take their fair share of responsibility and accountability. And when the issues arise, they step up and take care of the issues. And the last one is managing both the direct and indirect costs while ensuring equal credit is given to all the people that are contributing, right? So when it should be a business proposition, it should not be that we build up all this platform and do all this work, and there is no value generated from that. It's not going to be a sustainable solution if you did that. So with that, I want to close it, hand it off to Andy.
Yes,
Thank you,
Anil.
So I wanted to talk a little bit about some potential concerns we can see from the driller's perspective, a little bit of how this is manifested currently, and then how we want to address it going forward and make the lives of the drillers really as impactful as possible in the overall operation of drilling a well. So on the screen here, I have a bunch of different things that would be going through the drillers' heads constantly. This among 1,000 other things, but I mean anything from optimizing, watching over the set points, what's the weather going to be like today, upcoming jobs, and we're really taking all of this information and squeezing it into a shorter amount of time now. I love to point out a while back that, like, when I worked worked in West Texas working floors, I think we got an attaboy and jackets and everything for a 22-day well. Nowadays, when I was working in performance engineering, I was trying to explain 18-day outliers. And so we've really gone lateral links that are much longer and timelines that are much shorter. So all of this information isn't being spread out over 30, 40 days like it could have been a while back. Now you're really condensing what he has to focus on and how frequently he needs to focus on it. I think that's another key impact to this, or another key aspect to this is it's not just, I know every stand I need to focus on this list of things. It's some are every stand, some are every minute, some are once a day, some are constantly throughout the hour, some involve safety, so on and so forth. So if we look at the evolution of drilling out in the field, on the far left of the screen here, you'll see a very analog state. It's pretty much every rig operating as an island. So we have a well site supervisor out there making all the decisions at the well site. Not as sophisticated as we are now, but it was effective for the time. Really what we're seeing a lot of now is we've had a lot of advances with technology, whether it's phones, internet, and more recently the big data models, where we're working to the far right end there, where we have a complete cultural shift. Instead of one person at the rig site that's running everything, we have a lot of models off rig that can either interact directly with the rig or advise to the rig. And then we're seeing the well site supervisor become a little bit more of an oversight instead of necessarily making every last call. And I think, something like RSS downlinking probably wouldn't have been nearly as possible if you're talking about the analog state on the far left. But as we go to the right, we get a little bit more advanced. We get a little better ability to use different tools out there. And we're seeing that from left to right, we're getting much more efficient. And again, we're seeing the longer laterals with shorter well cycles. So that's, I think, a key component in really what's already started this cultural shift. So what we're really doing to try to address all of these different things that could be going on for the driller, how much attention he is giving to everything, is trying to take out of the button pushing, the busy work, those kind of things from the driller, and say, hey, what can we offload and make him more being an expert of what he should be, which is keeping the crew safe, keeping the wellbore stable, and making sure we're mitigating our dysfunction. So we have about 42 rigs in our fleet right now where we're using automatic point execution, so we can upload a plan ahead of time And we'll follow that plan for different sections of the well in terms of drilling parameters and different tech parameters. And really, the focus is to get to the point where we're making real-time updates by real-time I mean every 30 seconds or so, or between events for certain things. So if we notice we didn't get a good zero or tagged bottom improperly, before we tag bottom again, we want to make sure we've fixed the issue, and trying to rely on some models to help us with that. Like I said, we are doing this on 42 rigs currently, and so that can take out thousands of constant just adjustments the driller will be making, allowing him to focus more on the rig floor, work on training the crew a little bit better, really addressing watching for kicks, those kind of things. It really can't be overstated, though, and I think as mentioned previously, the cybersecurity aspect of this is one of the most critical, especially when you're talking about off-rig platforms potentially impacting the rig in any way. It's pretty much a non-starter. We can't have any events at the rig in terms of somebody getting hurt, serious environmental impact issues. So needing to make sure we need to avoid those. And really, for that, this requires scale. This isn't something we can do one-off here and there. This isn't something that you can pick this model and this rig and just kind of make it very difficult one-off, one and two really integrations. This needs to be something you can do at a larger fleet. So luckily, I think we've been fortunate there. I mean, designing our own rigs and owning our own rig controls, but it is something that needs to spread more and more as we go throughout. And then I'll hand off here.
Thank you, Andy. Travis?
Hi, morning. Thank you, IADC and NOV for sponsoring. So I'll kind of give a little bit of info from Transocean's perspective. I think, thinking about it, we would like where, new equipment comes on, where all of the service providers are constantly bringing on new equipment. Robotics are, kind of state of the art now within the industry. How do you bring not just like, specific OEM robotic systems in, but, there's lots of robotic integrators out there with tons of experience. How do we leverage their skills and expertise to make that integration easier? So, I think there's a way here where, a piece of equipment can show up to a rig. There's literally, an Ethernet type connection. You plug it in. Now you've opened up the envelope across all of your existing pieces of equipment to use that data accordingly from one piece to another. And it might not just be, downhole, but it could be to your safety systems. It could be to your, personnel systems. It could be to your procedure system, and getting real-time feedback there through those. So, kind of what does interoperability mean? I think we've covered that already, right? It's an exchange of information. It's an open architecture that allows that transfer of data between systems, and it's a consistent interface. I think without those two things, you're really going to struggle with getting adoption across the industry, across all the different possible combinations out there, whether it's offshore, land, and all the various interfaces in between. Use and acting on information, right? So we get that open architecture. Now you have to do something with it. And how do you use it from downhole tooling, completely different, to maybe your operations procedure system, that's done completely independently. So, being able to go back and forth across different avenues is really important there. And then really a predictable outcome. And that predictable outcome, I think, the way we tend to think of it is kind of a classic data governance framework, right? Starting at the bottom, what are the business objectives of everybody? Right? And we may all have different objectives, and that's perfectly fine, but you have to kind of be able to harmonize what those are so that you can kind of come up through the data work framework to get somewhere. Flexibility, it's got to be that flexible where, it works for Transocean as well as it works for, H&P or for NOV or for anybody else in the value chain. And ultimately our customers, right? So, Chevron, Exxon, any of the other players out there that need that data back and forth. Stewardship is, I think really lies within the drilling contractor. I think we'll all kind of talk about that. it's our hosting of it, which takes you kind of to the security risks, right? And I think we all know that anymore rigs are not floating islands, right? They are connected. We have now cloud instances where we're using large language models or other large machine models to bring data back because of compute and everything else. So there's that, and then I think that's a big role of the drilling contractor is that stewardship section. Data quality, obviously you have DSATs doing data quality today. That data has to be usable, right? If you can't get that predictable outcome, you can't trust it. The same way with the data integration piece, right? So, again, it's got to be usable. You have to be able to rely on it to give you a consistent output. Security and privacy, whether it's, things like, people data or machine data or just, in the worst case, infiltration of inappropriate acts coming in, trying to do sabotage in the, in the really worst cases. You have to be able to protect that accordingly. And then architecture kind of goes back to, an open architecture that's consistent. What might that look like? I think, kind of simply in the center there, you have that aggregator that's bringing in, whether it's third-party services, casing tongs, anything that it may need to come on and off of a rig. You've got all the different digital solutions, well control equipment, right? I mean, there's a number of different well control equipment models out there from different providers, and they need to be able to come in and be a part of the system. Having them left out in kind of their own island just doesn't really help us in the long run. MPD, certainly for offshore, MPD and using MPD to drill a better well, give a better well, complete a better well for long-term viability of a well value. It's an incredibly important part of the value chain these days. Just in the MPD space we see offshore. Downhole automation directly links with MPD. Red zone management, right? We're ever increasing focus in having people in the right spot at the right time. Being able to, in real time, use that with machine data to your procedure systems. Like that big combination is a really important driver. And then, kind of the newer frontier of robotics, right? Being able to bring in a robotic system that does a portion of something really well and use it effectively without having to, I have a screen for my robotic system, I've got my drilling control system, I've got, all of these different screens. I looked at a offshore drilling rig here the other day, and they're up to like 20 screens all in the drill shack, right? It's just information overload. So how do we use something like DWIS to combine that and bring it back together? I think is the interesting part of what DWIS brings to us. That's where I kind of wrap up, and I think Robert can kind of expound from there.
Thank you, Travis. Robert?
Okay, welcome. Believe it or not, we didn't synchronize our slides, but I think we are very much aligned. And I will talk about the value proposition. And that aligns closely with the first layer of basically defining business objectives. Because why do you want to do DWIS? Why do you want to be interoperable in the first place? And in order to answer that question, basically, you have to define what your goals are. Where is your value? And we made this slide. It's not, in that sense, accurate in the sense that it's completely one-to-one, but it is a good guidance for the discussion. And if you look at the bottom layer, that is processes that are directly basically contributed to the stated goal here in the slide, and that is basically drill the hole in the shortest amount of time to an acceptable quality. I think it's important to define that goal up front, otherwise you cannot have a meaningful discussion. So technologies that contribute one-to-one to that are, as stated already, MPD, for example, downhole models, and all kinds of really important models, what happens down there, including design of bits and things like that. Then we have the middle layer. The middle layer is where the drilling contractors come in And predominantly and basically for this stated goal, our job in life is to keep the bit turning and drilling, nothing else. So if we have to do a bit run, better make it as fast as we can because we need to get the bit down there and start drilling again. And then we have the top layer. And the top layer is very simple. It is a supporting layer. It is predominantly cost. And if you do a stellar job in the top layer, nobody will notice in terms of the value stated here, making whole. Safety is one of them. If you do a stellar job, 100% safety, nobody will notice in terms of, hey, we're drilling faster. You have a safe rig, you're not drilling faster. If you have an incident or an accident, yeah, then people will start paying attention. So it is a grateful layer there. You do the best you can, and well, everybody says, meh, okay, fine, you did your best you can, but we're not doing it any better. So it brings us to DWIS in that sense. What does DWIS do? Unfortunately, the automation layer, rolling out automation, and I think the panelists here, we can all agree on that, it's not cheap. It costs money, it costs attention, and rolling it out is one thing. Maintaining it, making sure that's up to date, cybersecurity and all that, it takes manpower, it takes attention, focus, and unfortunately, money. So you have to make the best out of it. And one thing to do is how can that layer, which is the top layer, that's where the automation layer lies, contribute to the bottom layer? Who are the actors playing a role in that? And DWIS connects those layers because the bottom layer are often models. It is basically the very intelligent stuff that the service companies come up or other third parties or even startups, making the drilling process more efficient from a downhole perspective. But they need the top layer, and we need to open up that top layer to basically the bottom one as efficiently as we can make it, because that is where the value for our clients is. The value for us as drilling contractors is in the middle layer, and there comes DWIS again, connecting that layer to the top layer. And you have to also see this graph as this is one operator, contractor, one well. However, so for that particular situation, you could easily defend the bespoke solution and saying, okay, fine, we do something and it works. But our clients are working with multiple drilling contractors. We are working with multiple clients. We're working with multiple service companies. And then you see where the value of DWIS comes into play because the top layer is already costly. And now we have to connect each and every time in a different way to basically different parties. There's a risk for miscommunication. There's also a cost implication as well. And we want to make the entrance into our industry from third parties that bring real value as basically the bar as low as possible. Because the name of the game, in the end, that we all want to do is go to scale, roll it out. Per rig, per solution, we can do that. But the real challenge is now we have to do it over 40 rigs. And unfortunately for us, we don't have the luxury in the offshore world of having designed our own rigs, being fully responsible for everything. We are a bit dependent on a lot of other parties. So the intermediate layer of DWIS is becoming really important. And in the end as well is, and several of my panelists also referenced that, it is the quality of the data. It is what you measure, is that actually transferred all the way back to the office? How can you basically ensure that the quality of your measurement is contained within your measurement and can be worked on? And the other thing is that I don't want to basically put under the rug, so to say, is the amount of copying of data that is going on. So the DWIS part of semantics is going to be really important as well. You measure something, and I think it's a true statement that that data is copied at least 5, 6, or 7 times across different platforms until it arrives at the cloud, for example, where somebody has to use it. that probably doesn't know, it's probably pretty certain that the identifier in the first place is not the identifier in the last place. So semantics will help that enormously for human users to find it. And I think with all the AI, it is really important that AI gets the information, is what does this signal mean for proper training and things like that. So in a lot of ways, I think DWIS will be the glue between all our different layers, and it is something that, I think there's no choice. We have to go forward with this, and it has to be supported by a lot of people. With that, I will go to my next panelist.
Thank you, Raphael.
Yeah, thanks, Avinash. So first of all, thanks IADC for the invite and DWIS for organizing and OV for sponsoring. Really good to see the level of alignment I think we have here in the room. A lot of the biggest players here in the market on the drilling industry, and really pushing for automation and how much interoperability plays a big role there. My goal here is just to share the experience that Neighbors has. We have joined this journey quite some time ago. And the way we approach and our side was really trying to make the rig as a platform, right? And what do we mean by that? We wanted to give the driller the capacity to operate in a seamless way, regardless of the equipment he had in front of it. And we wanted to unify it. So of course, for business reasons, making more efficient, making it so that we could interchange drillers from different rigs. And of course, with a vision that the digital revolution was coming for us. And I think it's obvious how much progress we have made so far. So the driller will have on a single system based on our platforms, SmarterOS and Rig Cloud, access to the rig equipment control, right? Access to our digital solutions that Neighbors has developed. And of course, as an open platform, we want to also give access to other parties, some of our customers' apps, some of our even competitors that have developed technology, that they also had a seamless way to integrate that technology in our rigs. And the way we did that was Neighbors, as many other drilling contractors, grew organically by buying rigs and also by manufacturing rigs. And the specifications of those rigs have evolved with time. And of course, we needed to deal with that complexity of different types of machines. And so the way we did it was to separate that machine control. We put it on a lower layer that understand the different type of configuration that deals with the different IOs and drives that we have, with the different communication protocols. And on top of that, we create this automation layer with the automation framework, with the applications technology that could be common between rigs. So again, that enabled us to give a seamless experience to the driller and also have something that is technological standard that we could enable for others to work with. So that was really the phase one. It started pretty much 10 years ago. And what we did for the last 3 years was to really, okay, we have managed the complexity of our own rigs. Now we want to go to our customer rigs. We're a vertical integrated company. We manufacture equipment as well, not only operate rigs. And we wanted to give those customers the capacity to operate some of our digital tools as well. And I think what helped us was really to understand the complexity that they were facing as well, understand the different types of equipment they had, and create that standard interface that I think it's been talked about a lot about it here, so we could then connect that same automation layer that we have developed, that we have operated in our rigs, that we had 10 years of experience, to then be able to provide that same level of automation and digital access to those players. And of course, on top of that, we wanted to create a standard app integration layer that would enable other parties to provide their app solutions. I put a couple of examples there. The small number that you see represents the number of different apps we have available. And that, again, helps on the interoperability side on the different app providers to come and be able to interface with that. And I think we mentioned a lot the cybersecurity relevance here of making sure that the rig equipment is protected from external actors, right? So that was our approach for the framework. And it's really the lessons we have learned. It's a multi-party collaboration, right? We have the E&P, the rig contractor, of course, the automation provider, the ADCS, the equipment manufacturer, and of course the service companies with their apps. And everybody needs to play a role, and everybody needs to win. If one of those parties get left out, then you're putting your project at risk. And of course, most importantly, the driller. The driller is at the center of it. He is at the end user. I think Andy brought some really great points on how much he is responsible for the safety of the drilling crew, the integrity of the operations, and we always need to make sure that through the DOE's framework, we give the driller also the capacity to make decisions and again, interchange rigs without necessarily having to relearn all that. Managing the change is key. We're talking about changing how people do their work, and that requires, of course, effort and alignment from all levels of the organization. Sometimes we focus too much on the rig and the stakeholders are not aligned. Sometimes we focus too much on the stakeholders and then the rig crew is not necessarily aligned. They think that there's a risk for digital to come there and displace them, and it's not the case. We're really trying to make more of the resources we have. Onboarding is really critical. And of course, the aim is to really have consistency, deliver the wells on plan, and performance ends up coming as a secondary effect. And last but not least, when we have to have big plans, we need to have ambitious goals, but we need to start in a way that, again, we don't overwhelm the field crew and how we're implementing the technology. So stacking is always the right way to do it. And I just put it here on a small example. I come from the aerospace before joining the oil and gas 18 years ago. And at the time I did my thesis on university, we were studying how the GPS-based navigation systems could really revolutionize that industry, shorten the spaces between takeoffs and lands, and really support the growth that was expected for that industry. And you can only imagine how many airports we have in the world, how much it needs to be updated, and the level of investment that is required. And just putting some numbers there, in 2022, just the FAA invested about $14 billion on that transition, and is expected to cost something around $35 billion, right? And of course, the bigger numbers compared to our industry, but I think the point is that really, to really have adoption across multiple of those parties, we will need that investment, as Robert was mentioning, right? Every single company here have already invested quite a bit of money in developing their own interoperable way of doing. And we're talking about now the next step, and it's absolutely needed, right? We need to be able to now interchange information between those systems, and that's going to require a fresh investment. That's going to require a new capital, and most of the companies are still recovering from that initial phase and that digitalization that started 10 years ago. And I think this is really important for us to bring, as well as how do we bring the economicity of that endeavor so we can really accelerate the adoption. Right? With that, I think we pass it back to Vinesh.
Yeah, no, thank you, panelists. Great discussion. What's interesting is we have, major drilling contractors, but there's so much alignment from what one is doing to compared to the other drilling contractor. I will start off with some questions. Every panelist here mentioned cybersecurity, and I would like to, start with Anil here. Can you talk about some of the issues you've seen relating to cybersecurity, and what have you done to mitigate?
It's a good question. So personally, we have not experienced an incident per se. I can say that because that not happened. So. But we were made aware of threats. There is threats always coming in. We have a cybersecurity CISO group within the company that covers all the companies, and they give us guidances every quarter. And we have like a quarterly review of all the IT OT systems. I'm responsible for all the OT, operational technology, and we take a different perspective when it comes to OT, because with the OT in OT space, you're going to have devices, equipment that is supported by a manufacturer a long time ago, and it could be vulnerable, and we want to be aware of things, right? So it's not like everything is going to be 100% foolproof. That's the nature of our business. But we want to mitigate it. We want to make sure that there is segregation, there is separation, identify the risks, and mitigate the risks, right? So, and we also have a plan in place, like what if something were to happen? How do you contain it? How do you keep it from spreading to other locations and all that?
Perfect, thank you. And Raphael?
Yeah, it's really leveraging what the tech industry has really evolved, right? We try, of course, focus on giving, leveraging that capacity, and of course, as you mentioned, separating the OT, the operational aspect, how we control the machines on the rig, and completely isolate to the external world, to the IT and to the network through a firewall, and trying to, of course, keep that firewall as updated as possible, leveraging the new releases, right? So that interoperability, I think, comes into play because we need to be able to continuously deploy new versions in a way that's sustainable across the rig fleets, right? So interconnectivity is really important. Recent experiences as well, we share with Anil, we never had any issues, but we do drills, just like we do well-controlled drills. We do cybersecurity drills as well. We had a big one end of last year, and basically we simulated if we had an attack, what we would do. And that generated a lot of discussions, a lot of action items. How do we make sure that we have the information at hand, right? If you lose connection on a rig today, can you still operate it? And I think is an experience important to share because when things happen, that you need to be prepared, and I think drills are a great way to do that.
I just want to add one thing there. I don't know, do you all know, like, most of the times where a threat comes in from? Do you all know? Like
Internally.
Internally, or it's usually going to be like something like a USB stick or somebody plugs in something, right? Yeah. It is internal, but it is external. External device plugged in is kind of the source of it, right? Or somebody clicks on a link that is external to the organization. And that is the context here, right? That's why I was bringing that up in my presentation, saying that we can control, we can plan everything internally, but if a service provider or if somebody comes on location and plugs in something, and if you're not set up to handle that and separate that out, that risk, then we are definitely exposed. You know?
May I add to that is and it's actually a perfect example, is what I'm seeing with cybersecurity it comes from a different world. And I think that we need to strive also for resilience in our operations. Because right now cybersecurity is mainly focused keeping the bad guys out. Cybersecurity guys, to my experience, have very little attention from how can we keep the things running if a system is down for whatever reason. They're very quick in shutting everything down. Yeah. So I want to make a case that also DBIS helps here. If you have standardized interfaces, you can have different systems basically talking to it. If one system goes down, you can have a way more seamless transition over to other systems, keep your operations running. Because last year showed basically we're very dependent on very few computer providers, software providers. And I want to make a case here as well, is we need to start diversifying it, and so that stuff doesn't basically spread out suddenly. And since you're working with one system, you're basically guaranteed that everything goes down if it attacks that particular system. So I see two things here. That and your basically your simulations, and you say, yeah, you need to be resilient. The rig needs to keep on going.
Put it at test. Continuously threat the system so you know you're protected, right?
Exactly.
Yeah, I think one thing to mention here, though, is, and I think we've touched on it a little bit, but just to highlight, is the scale, too, because, I mean, I think of it in terms of, if you arrive at location, there might be a gate guard. You usually need to check in with a well site supervisor or rig manager or something like that. If you're just walking around aimlessly, rig hands, or especially in the driller's cabin, a driller might ask you who you are, what you're doing, those kind of things if they don't recognize you. But usually if somebody's on location that's not supposed to be there, it's by accident, they showed up at the wrong rig, delivery to the wrong rig, something like that. When we're talking about a cyber attack, it's not somebody there by accident typically. I mean, it's very intentional, and we're not talking about one person, we're talking about a potential attack of thousands or multiple rigs at one time, something like that. So I think, yeah, being able to keep running, being able to shut out all the external, and really understanding you could have thousands of attacks at the same time is really something to highlight in this conversation. It's something that I didn't really understand that well when we started, but really working with our IT group and understanding how big that threat is has been helpful.
I do have a question from online. What is required for automated well control to be used?
DWIS? That was an easy one. Now, I think what is required is that, and to the point of our respective competitors here in the drilling world, but you need to talk about your values, the win-win situation. I know it's a very broad statement, everybody uses it, but it cannot be done if we don't connect all the layers together, all across basically our clients and our vendors. And it's, yeah, I mean, in that sense, DWIS helps a lot. So that part of the discussion is then over. You don't need to talk about your secret communication protocols. He says, I'm DWIS compliant, fine. Now let's talk about the win-win and how to do that. So.
Yes. So I think it kind of starts at that very bottom of, what's the objective here, right? We all have, all the drilling contractors probably have, well control manuals, but then, different customers want to handle it slightly different, and, what's ballooning, what's not ballooning, what's this, what's that, and, just being able to articulate what you want your output to be is really kind of, I see what the driver is for getting automated well control.
Yeah. And a very low entrance of apps, because one client has a Super B app for ballooning detection. Fine. If you have a platform that accepts, we activate the app, fine, now it's your ballooning requirement suddenly driving the process. And once again, DWIS is designed to be able to do that with all the orchestrating things there. So I think we have to strive for a very accessible system that can be tuned to several needs.
I think you mentioned it best, though, when you're talking about coming up with the objective. When we say automating well control, it's like, is that the detection? Is that physically shutting in the well? Is that the response after we shut in the well? And likely, long term, we want all three, but really you'd probably be starting with the models that are actually detecting and those kind of things. But I've noticed, anytime you talk about automation, it's, well, okay, what is your goal? Because what your goal is very different than another. I mean, just dealing with dysfunction, every customer is going to have a different outcome they want, and it'll be the same thing for well control.
And if I can share something as well, I think reliability, as you said, Dundee, it plays a big role here. I think we, as any industry, you start with your lower hanging fruits, and that's where you focus your energy first. And I think that well control, we are obviously leading with a great amount of responsibility. So I think it goes back to the analogy on the aerospace. The landing process is still done manually, right? Basically, the pilot's taking off whenever it's 10 to 15 meters or 30 to 40 feet from the ground. The pilot's still taking off because that landing has the biggest amount of risk on that entire operation of a flight. And I think well control has that aspect. It will be automated for sure. I think it's something that we believe now with big data, there's definitely great ways to make that detection more reliable. But definitely we want to take that step whenever we reach that Six Sigma level of accuracy, right?
Yeah. And combined with that, and Michael alluded to that in his graphics, is part of the DWIS is discussion about liability and actually logging certain decisions along the way. And I think especially in well control, that you need to have traceability of your decisions, and it's already built in. And we found that you can better have the liability discussion, okay, who's responsible for what, way early in the game. So you can basically discussion get a lot better than in that sense, so to say. But it's already built into it. And I think the liability, and Mike, correct me if I'm wrong, we're just starting it. It's going to be an interesting journey, I think, if we go full at it later on.
Thank you for that. Thank you, Brian, from Safe Influx for that question. We have another question from Bernardo from Noble. It's a little long here, so let me read it. Interoperability will certainly create value and enable automation, but on another hand, it will create new dependencies and shared liabilities. What are your thoughts on business model change and challenges industry will need to overcome the data silos and company IP roadblocks?
Yeah, it's a very, very good question. Yeah. Maybe I can take a stab because I was talking about the collaboration between the multiple parties. And I think that there is, of course, the risk aspect of now with more seamless integration between, you say, those 5 players, right? They all play a role in a certain specific activity that has been automated. Now, something goes wrong, who is responsible? And I think that tracing that data, I think Robert made some really good points that it's really important to understand from the different levels of the automation who is doing what. And I think, again, DWIS, I think it's key for that to progress because it's going to define the boundaries in a way that we all respect. But also comes the alignment as well. And when you have alignment, I think you can achieve much better results than our current baseline. So I think looking more for the opportunity side, I think that is absolutely a drive for us to do that and to break those and overcome those risks, because when you have, I think, alignment between all the supply chain, I think by all means the outcome is going to be much, much greater, right? But we need to continue thinking on, it's not a win-lose situation. We really need to search for again, defining which player plays what role and how they're going to contribute and aggregate value to the whole value chain, right?
I think added to that, we have to stop competing on stuff that's not our core business and really define what is your core business and basically cooperate on everything else. And basically a common backbone for data is, I think, something that is very worthy of that goal.
Yeah. I think it's a good question. We do that right now. I mean, we have applications where we have our own internal development going on, and the customer comes in and says that we want you to implement this RP optimizer, sometimes from one vendor, sometimes from a different vendor, whatever they choose, right? And we have to work with that, right? And we have to exchange the data in a meaningful way and be responsible, right? But it has to be a win-win, like Rafael was saying, right? It can't be just like, we're going to show up on location, everything has to be wide open, and then you're responsible for everything, but we get paid for it. That's not going to be a win-win proposition, right? So equitable value, I think, is going to be the key, right? IP aside, I think we've moved past the IP discussion some time back already. So people are open to adopting new applications, adopting even competitor stuff like Neighbors was talking about. So I think we're there as an industry. I think we just need to make sure that the third-party providers that are coming on location are also looking for a win-win proposition.
Perfect. Thank you for that question. We'll move on to another one here. This is from James from SLB Land Rigs. I'd like to hear the panel's thoughts on the current appetite in the industry for the level of investment required to drive the third-party integration and interoperability.
Wow. Where do we begin, I guess, yeah?
In our experience, it needs to be net positive, right? So I think there is definitely a constraint, a capex constraint. We're all facing especially over the last 2 years. I think we moved from a post-COVID area where rigs were coming back online, and I think there was appetite to invest more to an environment where we are more capex constrained. And I think when we see success is when we have a more obvious, and then go back to the low-hanging fruits, return on the investment. And I think that equation continues to be looked upon. Sometimes the farther down you go on the value chain, the more hard it is to justify that investment, and the time to return, it's becoming shorter and shorter, right? So we're now looking at within the year, right? If you say that we're going to recover that in 2 years, the project doesn't get sanctioned. It needs to be over the next 3 months, 6 months, and I think it's important that we understand that environment as well when we're discussing developing new technology and new product development, because we certainly need sponsorship as well from upper sides of the chain to really take a leadership role here and support it, right?
Okay, I have one thing to add there. I've been thinking about it since I've been part of the DVIS committee. I think my perspective on this is that you cannot just change everything, like drop everything that we've done for the last 3 years, 5 years, 10 years, right? And then start adopting a new framework, which there are two aspects to it. One is the risk of adoption and a risk of being successful or not, right? The liability and reliability issues. I think the best approach would be like take it in piecemeal, like as it's being developed, overlay that along with the current systems that are already in place. Like we have an edge solution. Most of the contractors have an edge solution, so maybe have that be the interface. So that's connecting over the DVIS protocol, and then that becomes the gateway to everything that is happening in the control systems. So everything is exposed, but it's exposed through a layer, right? So we would start there, and then if that is successful, obviously we can make commitments in terms of more capital investments to make it more the only layer that goes through.
Yeah, I think there's a point here that's perhaps being missed, that you bring out an application, you put it on a rig, there's a whole verify and validate phase that has to go through. And if you have a standard interface, then your cost suddenly drops on that, because now you don't have to verify and validate that piece. Yeah, you can really focus on the app and its interaction with the rig. Yeah,
But is that for every rig type, or is it going to be like you have to go through that with every different?
Yeah, that's so it's really difficult to scale an app up across the industry if you have to do it every single rig. Yeah.
So in my experience, though, I mean, we have done that, right? We have 4 different rig types that we work with within the company, and even if you certify like a particular vendor's app on one rig type and a couple of rigs that are running on a different rig, there may be a different challenge, and it's not because of the protocol or whatever. It's because they pushed out an update, like one of the Modbus registers got modified, and they did not inform us, right? So all of a sudden, these 4 rigs are working, but these 2 rigs are failing, right? So things like that will happen. So it has to be a continuous process, is what I'm trying to say. Like.
Okay, perfect. Thank you, James, for that question. We'll move on to Graham from NOV. He would like to thank the panel. But Graham wants to hear any specific successes or wins from rig operations that come to mind.
Well, yes, I think if you focus on the U.S. for a little while, we are now 4 miles laterals or something that are being knocked down pretty much without nobody's posting more in LinkedIn. That's how you gauge that it's become mainstream, right? The capacity to deliver wells. Andy made a great point on how he began his career and where we are today. And we have been tracking the increase in the lateral length of the laterals in the U.S., and we have been seeing how much production continues to increase while the number of rigs drilling continues to decrease. Right. So and that's enabled by technology, right? That's by having rigs that are more automated. We are now pretty much the entire on-bottom operations are done absolutely by the process automation piece. The drillers now just intervene whenever something is really abnormal. And I think that's what's driving that value chain to basically accelerate the efficiency, right? So I think you look at SPE, and I think all the conferences, you see so many examples of how technology has really transformed the performance levels. Yep. Would you all agree?
Yeah, I agree. And in terms of what we are experiencing now is that we are now looking at basically variations between rigs. And granted, the offshore is a little bit behind the onshore in that aspect, but we're catching up. So what we're seeing is that we're able to drive rigs to better performance by just leveraging the information we get off our other rigs and just really look at the details. How can we make it better? What are the steps that one rig is doing really good? And it's nothing new. I mean, like I said, the onshore, you're doing that for years now and spreading out, but offshore has some very specific challenges in that. And we're overcoming that now with our automation layer. But I would say that we're aiming now for the middle layer. Just be very consistent. And if you're consistent, you can start improving the operations like you see on land. You have consistency, and you're just gradually moving basically the goals upwards. But I think the challenge for us now in offshore is that, we need to start connecting the lower level apps to our base layer so we can bring that value to our clients as well. And basically also have a very good justification for rolling out that infrastructure. And we had to, because it's simply something you have to enable that. But that's why I said, I mean, it would be really, really good if we can have that standardized app uploading or talking of apps with each other. Because having data going one way is one thing. Sending control signals back, that's a total different ballgame. And I think that is something that we really have to start working offshore. Onshore, you guys already have it. I mean, if I see that, and to great success, correct me if I'm wrong, but that is where the real secret sauce is then.
I think I know the question is about operations, but I'm looking at it from a digital lens because I see the operational benefits already, like the best-in-class wells coming out. From a digital standpoint, the adoption of automation and the whole integration is really taken off in the last 2 years. Every product that we're putting out there, even from a customer standpoint, they're seeing so much value proposition. So before we had to do, like, for example, connection compliance, right? So we have procedures that are automated, and we had to prove to this customer on a weekly basis saying that this is actually adding value to you. This is your connection compliance is in place. You're getting best connection times you can think of. And now we don't have to, like, you know, they said, okay, fine, we believe in it now, let's move on to the next product, right? So that is, to me, the game changer. And this kind of plugs into the third-party services and other people coming on. There are a lot of potential to build more.
To what you're saying there, I completely agree that the fact that today we're talking about data interpretability instead of how are we going to get people to actually run this stuff, or how are we going to get people to use this stuff? I mean, if you go back 10 years even, I think all of us are, if you said, you know, what's your biggest concern, it's getting that adoption from the field. Now that's shifted a lot more, and it's really, I mean, I had a slide there about the innovation over the years, and a lot of people I think did want to stay in that I get a phone call or, you know, maybe at that web-based, but didn't really want to go much further than that. And I think we're seeing commitment from all parties where they want to go past that. They want the models, and they want a lot more information to be able to make better decisions, or they want decisions coming in and they can approve or disapprove of the decision.
Yeah.
I think for Transocean, we see it kind of in two areas, right? We have operations that are highly automated. You know, they've brought in casing services, right, which has all along been a long discussed battle of how to bring in casing services so that the, you know, tongs aren't like manually run in certain parts and semi-automated and all that, right? So they've brought everything into an automation layer that everything is fully encompassing. You know, offline stand building used to be, you know, some 90-some button pushes. You know, we have it down to, you know, 25, right? So, you know, but then you bring that to another area of operation, and the cultures are different, you know, kind of your point, right? And so we're going through it again in a different way and having some success. But then you have, you know, operators that are, it's new to them too, different culture. And so, you know, we're trying to bring all of that together, you know, in that automation journey. And it really is, you know, both parties working together, right? Our customers aren't always at the same places, maybe the operate or the drilling contractor, and sometimes we're behind or we're ahead or just in different places and different cultures, and so, you know, you're trying to combine all that together at the same time.
So on a similar note, aside from everybody here mentioned cybersecurity, everybody also mentioned the financial aspect. And then we have 5 major drilling contractors here. From your perspective, do you think operators are paying their fair share in this interoperability transformation?
Yeah, I'll going back to the point of the previous example. I think we are going through this transformation where we are doing more with less. So of course, for the supply chain side, that's the challenge. We have a more available number of equipments that are being outperforming, and the way I think we are approaching this, at least at Neighbors, and I think many other players are taking the similar approach, is to try to share some of the performance gains as well, right? So, and I think digital play a big role. I think in the past, because we didn't have consistency and we're always depending on the driller, and they do a great job, but Andy, I think, showed, again, very graphically how much they have in hands. And of course, with the attrition of our industry, it was hard to really commit to an outcome when you have so much variability on the performance. I think digital closed that gap really well, and we now have more confidence that we can drill that well on that period of time, and we can actually beat that curve. And I think, at least going back to your question, Avinash, how can we redistribute the fair share? I think performers here, the performance gains plays a big role. And that's how we are now trying to evolve the conversation to say, okay, we have that technology, and we believe that that technology will make that well operation more efficient. How can we capture some of that efficiency gains as a partner, right? So I think there's definitely an avenue for that there.
I mean, I feel like, you know, there's certainly operators out there that get the value of this. I think, you know, where DWIS comes in is, you know, can it provide a solution that makes that barrier of entry less, right? There's solutions out there that, you know, while they may be economical, they take a ton of rig time to implement. Or, you know, you need to spend 45 or 30 days or 90 days, you know, just integrating the system and having, you know, some sort of ability to bring that out of service time down, at least for us offshore, I think is really one of the major hurdles out there is, you know, that, you know, just being able to sit quayside and do data integration just isn't a viable option for any of us.
I think from our perspective, yes, there certainly needs to be some kind of sharing of the basically the wins, because 2 or 3, 4, 5 years ago, clients came on board with their whole automation suite and third parties. We never saw anything of it except for making the rig available. And right now, a lot of that is pushed on the drilling contractors on basically our dime that say, hey, we need to have a connection with your cloud service, we need to have a connection, this and that. And yeah, in the end of the day, our clients are reaping most of the benefits in the end. So certainly there needs to be a discussion, say, hey guys, we're rolling out the whole infrastructure. Let's now talk about, okay, how can we basically make sure that the wins are actually wins for everybody in that sense.
Oh, that was great. Thank you for that. We have a question from online from Tatiana from Neighbors. Is DWIS also talking about liability changes as different systems get integrated into the rig control system?
Okay, so you have to go read Robert's paper, I guess, which started the discussion into liability and limited liability, which is a contracting issue. DWIS by itself is really focused on the technical issue of getting this interface going, yeah? And leaving the liability down to the lawyers,
For the contracts.
to the legal side.
Yeah.
Yeah.
I think I mentioned it for the slide deck also. The contracts are going to be the key when we definitely want to open it up. I mean, obviously, when things go well, it's all good. We can share everything. But when things don't go well, we know how that goes, right? Usually, yeah. You go for the biggest neck to grab.
There's a standard framework in there just now to limit
Yeah.
liability and how liability is handled on contracting and so on.
I think from what I heard from the discussions on the DWIS committee was that is going to be discussed at some point, right? Once we get to
as
that,
we get deeper and deeper into
Yeah.
it. Yeah.
Yeah, it just remind me of a conversation we had with John Hansen. Some of you may know him. He's a visionary in our industry, and he was talking about how blockchain technology could play a role here, because I think it goes back to a lot of traceability of that data. And if you look about all those different digital players working offsite, they are really transacting between each other and giving data, transforming data, put into another system, and again, goes back on how can we trace back and understand where that chain got broken. So hopefully there is some technology, going back to your point, John, how the more I think the technology supports overcome the challenges, the less we need the lawyers to be describing this with words, right?
The way we are kind of handling it right now, because we already have some integrations with third parties, is basically building interlocks in the control systems in place. So let's say that communication is down for whatever reason, we know what to do, right? The system is not going to stop working, the rig is not going to stop working. You're just not going to receive that feed that you're supposed to get, right? And the show must go on, right? So the rig will continue to work. It's just there will be an indication like COM loss error or something like that.
Yeah, and I think it's intrinsic to DWIS as well. I mean, we have safe mode management. What happens automatically if you lose a signal or an event happens?
Perfect, thank you. Another question from online here, from Eric. Interoperability can help reduce installation time and costs, but can it also open new opportunities, like taking advantage of measurements or calculations provided by other parties?
I certainly think so. We are basically installing a bit of an open platform on our rigs. And yeah, we're basically opening it up for apps to use the data. And we're not sending control signals. It's just that you can, and installing sensors is then basically putting it physically in place, announcing it to the network, I'm here. At least that's the pie in the sky we're working on. And then somebody else can just pick up that data and say, hey, I'm going to use it in my app or something like that. Because at the end of the day, measuring data, it should not be a goal by itself. I mean, measuring data, we do it for a certain purpose. Make a certain decision, a business decision, or logistical decision, a drilling decision, or something like that. Train a model to make those decisions. So you should not be basically blindly go, we have to measure everything and all that. We should have firmly our end users in our sites. And for example, the drillers, what I see now is a little bit more they're going to process operators, because if you see in our endeavors to basically raise the bar, they're questioned about what we call nano KPI decisions. But in essence, what it means is you're a process operator. You run your process, and you have to make sure that all the little things are the best you can do. And drillers, of course, can only do 5 things. RPM, weight on bit, and all kinds of stuff. There's 5 numbers you can address for drilling. And other people need other data. So long story short, yes, I think rolling out that stuff opens the door for a lot of useful stuff.
Yeah.
If we make it easily accessible.
Yeah. I think we do that to some extent already, because on the edge system, we have a data science team working on all these models that are trained in the cloud. They push to the rig and they're running, but that team is not directly controlling the control systems codes. It's completely separate. They're almost treated as a third party, right? So when they're sending some recommendations, set points, whatnot, those are only recommendations. The control systems, the driller can choose to use it or not, right? And based on what level of integration we want to put in, we can put in, So I would say that the same approach we'll take for any third party coming in using DWIS interface.
Yeah, and on the DWIS is a semantic signal, right? So you plug in, you get the not just a signal, but information about it. Or you can ask for a signal by supplying semantics. And it's kind of key in there, and it's definitely built out. There's vocabulary for it on the site, which is massive, and so on. But it's a really important piece, not only getting a signal, I want more weight on bit, where's it measured, what's the quality of the signal, bandwidth of the signal, and so on. And within DWIS, as soon as you start digitalizing everything, you really need quality data. Yeah, you have to know the quality of your data, otherwise you end up with apps that are just garbage in, garbage out sort of stuff. Yeah.
And I think this is really what drives the goal, right? No one company can solve all the problems at the same time, right? And I think that is, again, under a CapEx constrained environment, we really need to make the best out of that investment, and I think that's what diversify. And again, the platform needs to be open. As Anil was mentioned, when we integrate other apps into our platform, that means that they can do that portion of that activity better than we can ourselves, either with our own technology or by having the driller to make those decisions. And I think that's what's really driving the acceleration is the fact that now you can pulverize the development into multiple parties, and they can come and share that standard interface that I think DWIS is proposing to really be able to get to that final end faster, right, where they can add their value to the share.
Yeah, I almost see this as a requirement long term. Right now, we like to pride ourselves on if we build a product, we're building it from the driller up. And it's focused around the driller. And if you look at it, a lot of times an application comes out, and when you're doing your research and asking the drillers, how would you handle this? What would you do to this? Almost always you get a, well, it depends. And based on whatever mud weights, or it's based on what part of the well I'm in, or am I rotating or sliding, or this or that. And I mean, if we could just have access to all that information at one time, rather than saying, well, we can get to a certain place, and then from the driller, he has to configure it, and we have to have all these options for configurability, because we don't know what section necessarily, or we don't know what the mud weight is, something like that. It makes it to where this is just very configurable and more set points for him to be thinking about. And we want to get to the point where this could go into a model and take a lot of that work off of a driller.
Perfect. Thank you. So let's try a rapid fire question here. Pulling out the financial aspect, pulling out the cybersecurity aspect, what's that next barrier that you see?
Yeah, for me, it's the reliability and accountability. I mean, those are the things. If we can tackle that, I think that takes care of most of the things that we have covered here, right? I mean, obviously, the win-win will come anyway with it, yeah. So everybody takes ownership of their set of the issues and ensures that it's reliable. The app that they're developing, the data that they're putting out, everything is true checked, and then we do our part as a contract.
How do you see legacy systems then? I mean, legacy,
It's a very good
build,
question.
right? You've got lots of existing things and changing them over. Not, I mean, even with a DWIS framework isn't simple. Technologically feasible, but not simple.
So we would have to work with the OEM providers in that case, right? So as a rig contractor, we can do so much, but beyond that, if there are limits, restrictions that we're hitting, then we would have to work with somebody to do that.
For me, it would be, the thing we have to work on is what I call system states. We're spreading data out to a community that is not directly interfacing with the process itself. And there's a lot of what they call tribal knowledge in our industry. And now we have a lot of people looking at data that don't have that knowledge, or looking at it just from another perspective. And some things mean different things to people when you look at it from a 30,000 foot or 5,000 foot. I think that is something we have to manage so that we get consistent decisions every time. And a particular example of that is in well control, where basically the status of your BOP is a state of your BOP in its entirety. It's the BOP itself. So the color of different components means something for the whole BOP. Whereas if you are a piping engineer, the color means something for you for that individual component. And then you get confused, because it should be red instead of green or something like that. Whereas, for example, if you're a process engineer working in refineries, it's probably perfectly fine because you're used to seeing that kind of stuff. So it's a small example, but I think that is something with the rollout, and hopefully it happens, because that basically means we're successful, that we're getting all different parts of the company contributing to that rig, but we have to manage that as well. I think that's very key, especially in the more critical well control applications.
Yeah, I would add, of course, I think we mentioned quite a bit here, two aspects. The data quality one, we still have a lot of rigs, especially when you go to the international space, where those sensors have been there for I don't know how long, and sometimes not always calibrated. And when you start making decisions based on that data, and we don't have the human eyes there sometimes to kind of, we're integrating was one of our customers' rigs, and when we went there, we realized the block position was off by, I think, 4 feet, but all the crew, they knew it was off for 4 feet, and they were operating like that. It was like, okay, automation system cannot handle that. You need to fix your sensor, right? So I think data quality is very important. Second element is more on the human side. I think, of course, is the management of change. We need to get the buy-in of those the people working and putting their hands in, and it's a change on how they work. So I think there is not enough amount of effort to really demonstrate to them immediately what is in for them, right? So they are part of that circle that requires also to be a win-win. They need to see that their job is making it easier, right? So going back to example of the driller, we have multiple ROP optimizers connected to our platform. We basically completely isolate that from the driller. He doesn't know what is actually being run, because for him it's seamless. And we try to manage that complexity, take that complexity away from the rig side. So managing the change is important too.
Okay, I think we have time for one last question. It looks like an easier one. What percentage would you say of land rigs are currently equipped with all of the hardware required to enable this level of interoperability?
Well, if you focus here on the U.S., I would say it's a higher percentage compared to internationally. I would say it's close to 80%. We are really focusing on automating AC-driven rigs. We talked about, okay, how can we expand the technology to DC? That's definitely going to require some additional level of investment. So the focus has been on the AC. So you would all agree, I think in the US, 80%.
Yeah.
Internationally, maybe a 40%.
I can speak for Patterson. We've made that a big push since COVID, since around COVID time, to get all the edge deployments done and all that. Basically, the infrastructure is in place, so it'll facilitate the communication. But the one-offs where we do have an OEM limitation, we do work with them directly. So technically, yeah, I would say that majority of our rigs are capable of doing it right now. So to me, the DVS is another layer on our edge platform. We could use it.
Well, thank you for all your replies, and everyone online, thank you for the questions. I know there's several more questions we didn't get time to answer, so I apologize for that. If I could take a couple minutes here for some upcoming events for the DWIS group. We have one coming up on March 7th, the DWIS Industry Engagement Consortium. That's actually going to be in Stavanger, Norway. But you can go to that website that John mentioned earlier and get more details. Also, we have DWIS demonstrations throughout 2025. I think the next one is on February 28th. You could definitely go online again at that website and register to get involved in those. So for some closing remarks here, thank you again for all your responses, the rapid questions, great responses. I appreciate the time you put in to get some slides together, and also take time from your day to come and have this discussion. Also, I'd love to thank NOV Rig Technologies Group. Again, without them, this today wouldn't have been possible. We would also like to thank Matt Isbell for organizing this. He sits on that DWIS committee as well. So thank you, Matt. So on that note, thank you, and please join us on our next session.